Hi, and welcome to my calculus clinic. This is Dr. Ghada Nakla. Today we are going to look at how to apply the chain rule to differentiate different expressions. Okay, so let's take a look at the first question. Y equals 2x minus 3 to the power of 5. There are two ways to look at it. The first way is to say let u equals e to 2x minus 3. Let u equals the bracket. In this case, y is going to be equal to the bracket to the power of 5, and the bracket is u, so it's equal to u to the power of 5. Let's differentiate. Du by dx is equal to 2. The x will differentiate into x to the power of 0. If when you drop the power, this is x to the power of 1. If you drop the power, so 1 minus 1 is 0, x to the 0 is 1. And the minus 3 differentiates to nothing. And then y to the 5, so dy by du is equal to, put the 5 down, and then decrease the power. When you decrease the 5, 5 minus 1 is 4. So it's 5u to the power of 4. Let's go back to our question. Dy by dx is equal to du by dx multiplied by dy by du. Which means it's this line over here. These two multiply together, which means it's du by dx, and du by dx is 2, multiplied by dy by du, which is 5u to the 4. And I know that u is 2x minus 3. So 2 times 5 is 10, bracket, 2x minus 3 to the power of 4. Because u is equal to 2x minus 3. That's one way to look at it. Another way to do this is what we call the quick chain rule. And with the quick chain rule, you go dy by dx is equal to, drop the power down, so it's 5, and then the bracket, which is 2x minus 3, decrease the power. When you differentiate, you decrease the power. So 5 minus 1, which is 4, so the power of the bracket will be 4. So 5, and then the bracket to the power of 4, which is 1 less, and then multiplied by the derivative of what's inside the bracket, or basically differentiate what's inside the bracket and multiplied by whatever you've got. So let's differentiate 2x minus 3. 2x differentiates to 2, minus 3 differentiates to 0, and that is the answer. So you end up with 5 multiplied by the 2, which is 10, and then 2x minus 3 to the power of 4, which is the same as the answer we've got there. So there are two ways to apply the chain rule, either the normal chain rule or the quick chain rule. We're going to apply it a few times in this presentation so you can actually learn it. So let's try another one, and question 2, and let's go y equals 3x plus 5 to the 6. And this time we are going to apply the quick chain rule. So dy by dx and with the quick chain rule, you drop the 6 down there, bracket, 3x plus 5, decrease the power of the bracket, so 6 minus 1 is 5 to the power of 5, and then differentiate the bracket. 3x differentiates to 3, plus 5 differentiates to 0. So this means you end up with 18, 3x plus 5 to the power of 5. And that's the derivative of y equals 3x plus 5 to the 6. Let's take a look at the different question. And in this case, we are differentiating y equals e to the 5x. Okay. The rules are, if you differentiate, if y equals e to the x, dy by dx is equal to e to the x. So when you differentiate e to the x, you get e to the x. If you differentiate, if y is equal to e to the 5x, then when you differentiate it, or let's instead of the 5, let's call it kx, then you end up with k e to the kx. So let's try it here. So this means dy by dx is equal to k is 5, so 5 e to the 5x, k e to the kx. Let's take a look at a different question. Y equals sine bracket 4x minus 7. In this case, I'm going to use the normal chain rule. So I'm going to let u equals 4x minus 7. Let u equals the bracket, which means that y is equal to sine the bracket. And what is the bracket? U. So sine u. And then you differentiate du by dx. And in this case, it's 4. 4x differentiates to 4, minus 7 differentiates to 0. Let's differentiate dy by du. And sine differentiates to cos, minus sine, minus cos. This is the positive x-axis. This is the negative x-axis. This is the positive y-axis. And this is the negative y-axis. And that's why we have a minus sign and a minus cos at the x and the y, negative x and y axes. You differentiate this way here. So you differentiate, so sine differentiates to cos, cos differentiates to minus sine differentiates to minus cos, and so on. So I've got sine u, sine differentiates to cos u. So cos u. And u is what? U is 4x minus 7. So let's go back to my question. And so dy by dx is equal to du by dx multiplied by dy by du, which is equal to 4 cos 4x minus 7. And that's the derivative of sine 4x minus 7. Let's take a look at something slightly harder. Sorry about that, just trying to extend the page. Okay, let's take a look at question 5. Y equals 5 cos 2 minus 3x. Again, let's say let u equals the bracket, and the bracket in this case is 2 minus 3x. Let u equals the bracket, and u is 2 minus 3x, which means that y is equal to 5 cos the bracket. Y is equal to 5 cos the bracket, and the bracket is u, so 5 cos u. And then du by dx is equal to 2 differentiates to nothing, 0, minus 3x differentiates to minus 3, because then x, the power of x will go from 1 to 0, and x to the 0 is 1. And then dy by du is equal to, what does cos differentiate into? Let's try it again. Positive x-axis, cos, negative x-axis, minus cos, sine, negative y-axis, minus sine. You differentiate this way. So cos differentiates to minus sine. So I'm going to have a 5 minus sine u, and u is 2x minus 2 minus 3x, sorry, 2 minus 3x. Okay, and then I'm going to find dy by dx, which is dy by dx, and that's equal to du by dx, which is the chain rule, multiplied by dy by du. This is the chain rule, which is basically those two multiplied together. Minus multiplied by minus, that becomes a plus, so plus, and then 3 times 5 is 15 sine 2 minus 3x. So the answer is 15 sine 2 minus 3x. Let's take a look at something slightly harder.